Hello and welcome to a new video. This is for Algebra 1. We're still working our way through writing linear equations, but this is either our last lesson or maybe a next to last lesson, but last lesson for now. So we're talking about parallel and perpendicular lines. Let's go ahead and warm up. If you just did the previous lesson, 3.4, then you maybe can skip this warm up because that's what this was about, was writing the equation of a line that goes through 2 points. But if you haven't done math in a couple days, then a warm-up like this will hopefully be a good refresher. So when we know 2 points and we want the equation of the line, we have to start by finding the slope. Then we use the slope that we find in one of these points either to write it in slope-intercept form or point-slope form, depending on either what the instructions say or what our teacher wants us to do or our personal preference. So in order to find the slope here, remember that we do x1, y1, x2, y2, and we plug it into our slope formula, which is m equals y2 minus y1 over x2 minus x1, which is really just a fancy way of saying, hey, subtract your y's on top, negative 6 minus 4, and subtract your x's on bottom, negative 2 minus 3. So that gives us negative 10 on top, negative 2 minus 3 is negative 5 on bottom, negative 10 over negative 5 is a positive 2. So our slope is 2. Then, depending on our personal preference or our teacher or whatever, we've got choices because we can write it in slope-intercept form or we can write it in point-slope form. If we write it in point-slope form, there's 2 versions of that we can have because we have 2 different points. So let's say you decide, or your teacher decides, hey, I want it in slope-intercept form, which is y equals mx plus b. And what we do is we pick one of the 2 points. I'm going to pick 3, 4 because it is not negative. I like to keep it positive, like I'm sure all you do as well. So we put the 3 and the 4 where x and y are. We put the 2 where m is. And then we solve this to find b, which is our y-intercept. So 2 times 3 is 6. And then because it's on the same side with b, we need to subtract that 6 over to the other side so that b will be by itself. So negative 2 equals b. And so in slope-intercept form, this would be y equals 2x because we found our slope was 2, and then minus 2 because we just found b is negative 2. If you instead are like, I'm a point slope person, which that's my favorite way to write it as well, then I'll remind you that point slope is the one that does y minus y1 equals m times x minus x1. And so if we use the first point, it'd be y minus 4 equals 2 times x minus 3. And if we did the other point, we'd do y plus 6. Remember the minuses in our formula, make it change to plus. So y plus 6 equals 2 times x plus 2. Okay, so you would not be required to write all of these answers based on what our instructions say, but you would need to write one of them. Now, that's what we've already done. So what is new about what we're doing in this lesson? Well, first off, we're going to talk about parallel lines. So I imagine, have heard of parallel lines before. If not, parallel lines are lines like what is pictured here on the screen, behind me, magically. Parallel lines are lines that never meet. That would be probably our easiest way to define them, or like our shortest or our most succinct way to define them. Parallel lines are lines that never meet. A different way of saying that, which I don't know why I decided to be particular about this, but another way of saying that is to say that parallel lines are lines that stay the same distance apart. So, I mean, that's essentially the same thing, but it felt different whenever I was making these notes. Stay the same distance apart. And then the third thing here that we're going to do is we're actually going to notice something over there about the slope. So we've done slope from graphs, where we basically make ourselves a right triangle sort of situation to help us count how much it's going up and over between these points. So this is going up 2, and this is going right 3. So our slope for this top line is 2/3. If I do the same thing on the other one, and it may be that even without having this visual, it would make sense to you, right? Once I draw this triangle and look at the rise over the run, I notice that this one also has a slope of 2/3. That should make sense that they have to have the same slope if they're not ever going to meet, because as soon as we adjust one of these to be even slightly different, then it's going to make them either head closer together this direction or this direction, depending on how we adjust it. So our third thing here, and the thing that's going to be most important for us for today's lesson, is that parallel lines are lines that have the same slope. Okay, so that's kind of our introduction to parallel lines. Let's look at perpendicular lines. So perpendicular lines look a bit different, right? Parallel lines don't meet, perpendicular lines do. This right here is an example of perpendicular lines. And perpendicular lines are lines that meet specifically at a right angle. Not a wrong angle, a right angle. So we will like notate that, especially once we start doing geometry with a box in the corner. You may have seen that before in like squares and rectangles and things like that. So perpendicular lines meet at a right angle, which is 90 degrees. Hopefully that's something that, hopefully at least some of those words are things that you're familiar with. If not, welcome to what a perpendicular line is, or set of lines are. Perpendicular lines are lines that meet at a right angle. And it should make sense that that's going to mean this is different whenever we're looking at our slopes than what we just had. So I actually left one of these lines the same. So this line up here that's going up and to the right, it still has a slope of 2/3. But I changed the other line. And if we look at this line and we draw ourselves a triangle here very artistically, well, this looks like it's going down 3 and right 2 for a slope of -3/2. So what's the connection here between these two fractions? We've got 2/3 and -3/2. Those are called reciprocals of each other. That's like the fancy math word for it, is reciprocals. An unfancy word for it that still gets the point across is that they're the flip of each other, right? If you flip 2/3, you get 3/2. But also one is positive and one is negative. And so that matters. So our second statement here, perpendicular lines are lines that have slopes. I didn't necessarily phrase this super well. I realized after the fact that have slopes that are opposite, meaning that changes signs, reciprocals, meaning we're going to change the sign, we're going to flip it, and that will give us a slope that is perpendicular to ours. Now, why do we care about perpendicular lines or parallel lines? Well, we have lots of places where we would like our lines to be either parallel or perpendicular. Architecture in particular is one. You know, your wall and your floor is hopefully perpendicular. Your ceiling and your wall is hopefully perpendicular. The ceiling and the floor are hopefully parallel. And that's not to say necessarily that I think architects are writing equations of lines when they're designing houses, but maybe they do. I don't know. I'm not an architect. My point is more that we have kind of this fascination as human beings with parallel and perpendicular lines, and so I think that's part of what kind of drives this emphasis that we have in Algebra 1 and geometry on parallel and perpendicular lines. The other thing I was going to say, with parallel and perpendicular lines is forces, how forces act on things. For instance, the force of gravity. There's going to be a thing with being perpendicular to the force of gravity and things like that whenever you start studying physics. So there is actually a lot that goes in with perpendicular lines as we kind of go up through our education. So example 1, tell whether each pair of slope is parallel, perpendicular, or neither. So this is a fairly common way of asking a problem like this, and students often get tripped up by this phrasing, parallel, perpendicular, or neither. What this is saying is that you have 3 options. Either they're parallel, or they're perpendicular, or they're not either of those 2 things. They're just if they're not those two things, they're just lines that meet and not at a right angle. So that's how we're going to go through this and figure this out. So what I would do personally is I'm going to look and see, okay, is it parallel? Because that's easy to spot because they have to be the same slope if they're parallel. Then I'm going to look and see, are they perpendicular? By checking to see if they're opposite reciprocals of each other. If that's also a no, then I know they're neither. So let's look at A. We've got 3 and negative 1/3. Are those the same number? No, so they're not parallel. Are they opposite reciprocals of each other? Remember that when it's not a fraction and you want a reciprocal, you make it a fraction by making it be over 1. Then we flip it, change the sign. We do in fact get negative 1/3. So A is perpendicular. Okay, B. If we have 1/2 for our first slope and 1/2 for our second slope, those are the same number. So this must be a set of parallel lines. Probably by process of elimination, we have a good chance of figuring out this last one. But just in case, let's look. 2/5 and 5/2 are not the same number, so this is not parallel. But even though they're reciprocals, they're not opposite reciprocals. It has to be both of those things. So this would end up being neither parallel nor perpendicular, or just neither for short. They're two lines, they have slopes, but they're not the special kind of slopes we're looking for. So, oh well. Let's look at some examples where we actually write the equations of lines that are either parallel or perpendicular to a given line. Like this one, we have a line they gave us, y equals 5x plus 4. They want us to write the equation of a line that's parallel to that one that also goes through -1, -8. And I also thought I'd take the opportunity here to have us do some graphing just to keep it fresh in our mind, or maybe to help us, just see it better, like to get better at graphing, So let's see. If their line is y equals 5x plus 4 and our line's parallel, and parallel lines have the same exact slope, then our slope should be 5. So let's start with that information. Our slope is 5. Then we're going to use this point, -1, -8, to either write it in slope-intercept form or point-slope form. You may be thinking, well, since you want me to graph it, I better go ahead and put it in slope-intercept form, which is not the worst logic in the world, but I am at some point in this lesson going to make sure to show you that it's actually pretty easy to graph from point-slope as well as from slope-intercept form. So just be excited about that. Let's say we wanted to use slope-intercept form. I'm making myself do that way because that's my not as favorite way. My second favorite way of 2. So -8 equals 5 times -1 plus b. I'll actually probably switch back and forth. So it'd be nice if you knew how to do it both ways, because it could be that sometimes it's easier one way than the other. I don't know. 5 times -1 is -5. So we're going to add the 5 over and get -3 equals b. So our equation for our line is y equals 5x minus 3. We're going to graph these two lines on this coordinate plane. So for y equals 5x plus 4, I'm going to start at 4 and go up 5 over 1 and down 5 left 1. Then I'm going to do the best I can here on making a line that doesn't look horrible. And we're going to see how that goes. It could have been worse. It definitely could have been worse. So that's the first line, the one they gave us. Our line, y equals 5x minus 3. If we've done this correctly and we graphed both these lines correctly, then this should end up looking parallel-esque. And I add the esque because of the fact that I'm not very good at drawing almost vertical lines or vertical lines on the computer. I mean, this is looking fairly parallel. So, not bad. That's one example of us doing lines that are parallel. How about two lines that are perpendicular? So in this case, our starting line is y equals 2x minus 1, and we want to come up with something that's perpendicular. So we're going to take this 2, and we're going to flip it and make it be the opposite sign. So right now it's positive. We want to make it negative, and instead of 2 over 1, we want it to be -1/2. That's what our slope is going to be. I'm going to put this in point slope form. So this would be our x1 and our y1. We're going to do y minus 2 equals negative 1/2 x minus 4. What I like about point slope, and what anybody who likes point slope at all likes, is the simplicity of plugging in the numbers and leaving it. What people generally don't like about point slope is that they feel like it looks more complicated because you're left with those parentheses there. So, and I get that, but I want us to try to hopefully be okay with doing either way. So our first equation, y equals 2x minus 1, we would put a dot at negative 1 and then go up 2 and right 1. And then, so I told you I'd show you how to graph in point slope. So here we go. It can be hard to go from the equation, but we know that the point it goes through is 4, 2, because they told us that. So what we can do is we can put a dot at 4, 2, which you can't get from the equation. You just have to remember to swap the signs. Okay, so we put a dot at 4, 2, and then we draw the slope from that point instead of trying to find the y-intercept and drawing it from there. Because the slope is true between any 2 points on our line, not just between our slope, or not just between our intercept and the closest points. So from 4, 2, I can go down 1 and over 1/2, or up 1 and left 1/2. And that gives me this situation right here. And you can part of this depends on how good you draw your lines. Using a ruler maybe is helpful, although I have trouble using rulers super effectively because it always feels like it's hard to get the dots all lined up and everything. But if you're trying to check to see if what you have looks like a right angle, if you take a piece of paper and you line up the corner with the angle you're measuring, if it is a right angle, it should line up on the 2 sides of the corner of the paper, because your paper has 90-degree angles, unless somebody's taken a bite out of it or something weird like that. But that's a way to kind of check. Now, if it's just that you're close to 90 degrees, but not quite at 90 degrees, it could be just that you drew your lines badly. But you might double check that you counted everything right, because that's an easy thing to mess up. Let's look at another one. We've got 2 more that are, one is a parallel situation, one's a perpendicular situation. This is the point where I encourage you to pause the video, try it on your own, and then see if you got it. Because math is very much something that it's nice to actually have somebody around that can kind of hold your hand through a problem, figuratively speaking, when you need it, right? And so this is kind of your chance to virtually have that pause the video, start it back up either when you get stuck or when you get an answer, and then see if you're right or figure out where you went wrong. So let's see. We're looking at parallel to the line y equals 1/3 x. Parallel lines have the same slope, so our slope should be 1/3. Our point is 6, 4. I'm going to do point slope this time to change it up so that I don't end up doing the same thing for both parallel lines. So this would be y minus 4 equals 1/3 times x minus 6. So in a problem like this, it's kind of like we have 2 answers, because it's asking us to write the equation of the line, but then it also asks us to graph it. So our first line, y equals 1/3 x, has a y-intercept of 0 because it doesn't have anything it's adding out to the side. So we'd have to think of that like it's a plus 0. Then we're going to go up 1 and right 3, or down 1 and left 3. If you're doing this and you're like, wow, I just really don't know how to graph lines, that's an earlier lesson. You can get on my channel and go back a few weeks and see some graphing stuff, and it'll be totally awesome. This other one, okay, it goes through the point 6, 4, which is here, has the same slope of 1/3. So here we go. This looks pretty good. Alternatively, we could take our point slope and distribute the 1/3 and add the 4 over and get slope-intercept form if we'd really rather use slope-intercept form. That would work, but that's how we do it. Let's look at example 5, and this one's perpendicular again. I'll do slope-intercept form on this one, although this point actually is set up to make it really, really easy if you know what it's telling you, which is kind of the key thing in this whole unit. Was the more you understand how these lines and the points on these lines work, the faster you might be able to get some of your answers. So we want perpendicular to -3/4, which means that we need to think about positive, and we need to flip the 3/4 to get 4/3. So our slope is positive 4/3. We're going to plug this in with 0, 3. Well, 4/3 times 0 is 0. So I don't need that 0 there. B is 3. So I worked that out, even though I already knew, because I'm knowledgeable about these things, that this was the y-intercept all along. 0, anything, it has to be talking about what our y-intercept is. So this equation would be y equals 4/3 x plus 3. But in this case, it didn't matter if we didn't notice, because we can work it out and get the equation anyway. So our first line starts at -5, goes down 1, 2, 3, and over 4. We're up 3, left 4. Could have been worse, could have been better there. And then 4/3 x plus 3. So I'm going to start at 3, go up 4, right 3, and down 4, left 3. And you know what? These look decently perpendicular, although I kind of messed up both lines a little bit right next to where they intersect. So that's an unfortunate sort of situation. Now let's talk about these special lines we have that are horizontal or vertical, have an undefined or a 0 slope. So this asks us to give an equation of a line that would be parallel to the line x equals 5, then give the equation of a line that would be perpendicular to the line x equals 5. And this is kind of just a chance for us to think through, what does this look like if I have x equals 5, which is a vertical line through 5, remember? If I want something parallel to that, then what do I need? I need another vertical line. That vertical line could be anywhere. So because it didn't give me a point to use, I could literally pick any number I wanted to. I could pick x equals 7, I could pick x equals -3. It doesn't matter. These would both be parallel, as well as anything else that has x equals a number. This doesn't actually technically even ask me to graph the other ones, so I don't have to if I don't want to. What about perpendicular? So you can probably imagine a perpendicular line here. It would be a horizontal line, right? So something that maybe looks like this. Those meet at a right angle. Horizontal lines are y equals a number. So for perpendicular, we could list something like y equals 5 or y equals whatever. You can literally pick anything, since it didn't give us a point for it to go through. If it gave us a point for it to go through, then we would have to actually pay attention to what either the x or the y value of that point is, so that we would put it in the right spot. So I think in a lot of ways it's easier just to imagine vertical and horizontal lines and think about what's parallel or perpendicular, but it actually does technically work with the slopes if you realize that, hey, the slopes of our vertical lines are undefined, which means that there's some sort of number on top but 0 on bottom, and our slope for our y equals lines are 0. So that means we have 0 on top and some number on the bottom. And check this out, those are in fact reciprocals of each other. As far as them being opposite of each other, we could make them be opposite of each other, like depending on what I pick for my number on top up here. Like if I choose for this to be 2 over 0, I can choose for this one to be 0 over -2. So it does work out, just like whenever we were doing normal slopes with normal numbers and fractions. Hey, thanks so much for watching. I really appreciate it. After this, we're probably going to look at inequalities, which should be fun. So I hope you'll subscribe and get notifications so that you can see that next video whenever it comes up. And don't forget to like the video if you liked it. If you didn't like it, just maybe, close the browser without doing anything. And I'll see you in another video. Thanks.